This little duck costs $399. Cute? Absolutely. But the interesting part is not the waddle. MicroDuck is designed to let developers train physical behaviors in simulation, move those policies onto a real robot, and keep iterating on the same desk. Official demonstrations show it walking, sitting, recovering from common falls, roller skating, and picking up small objects with its beak. That is a playful package around a very real robotics workflow. MicroDuck comes from Pollen Robotics, the Bordeaux team that joined Hugging Face in April 2025. Pollen was founded in 2016 by former INRIA researchers, and this is its second consumer robot after Re-Chi Mini. The difference is useful. Re-Chi Mini focuses on interaction. MicroDuck focuses on action, balance, locomotion, recovery, and physical behaviors people can retrain and share. Here is the core loop. A behavior starts inside Mujo Co-Warp, where thousands of simulated ducks can practice in parallel. The training repository uses PPO, a reinforcement learning method, to reward the motion you want. But perfect simulation is not enough. Tiny servos have friction, voltage limits, command delays, battery sag, and backlash. The project models those effects and randomizes them across training runs, along with the environment. That forces the policy to survive more than one ideal virtual world. A trained policy is then exported to the ONNX format and loaded by the robot. The official runtime executes that policy at 50 Hz. In plain English, MicroDuck evaluates what it senses and chooses new motor commands 50 times every second. Onboard compute is a Rockchip RK3566 with an AI accelerator, 1 GB of memory, and 32 GB of storage. Underneath, the software is split into Rust services. One owns the motor bus and safety loop. Others handle signed updates and rollback, Bluetooth, Wi-Fi identity, the gamepad, camera streaming, and depth sensing. They communicate through one local JSON RPC contract, so a controller, an app, or your own script can use the same command surface. Who is this actually for? First, developers learning reinforcement learning or embodied AI who want their experiment to leave the simulator. Second, classrooms and robotics clubs. A robot under 800 grams is easier to reset, safer to handle, and less intimidating than a full-size biped. Third, makers who want to modify behaviors instead of building every layer from scratch. The training repository already covers walking, rough terrain, fall recovery, sitting, standing, kicking a ball, picking from the ground, forward rolls, and multiple roller policies. Training locally requires a CUDA-capable GPU. The repository also supports Hugging Face jobs, which may carry separate usage costs. The larger opportunity is standardization. If many people own the same inexpensive body, use the same simulator, and publish compatible policies, physical behaviors can become easier to reproduce and compare. Schools could teach with the same experiments. Researchers could test multi-robot coordination without filling a lab with costly hardware. Developers could share not only a final policy, but the environment and training recipe that produced it. That does not solve robotics. Keep the limits in view. MicroDuck is a pre-order, not an independently reviewed shipping product. Several specifications remain provisional. Its software is open source, but the mechanical and electronic design files are not, and this is not a household robot that folds laundry. The real promise is narrower and more believable. A small, characterful platform that could give far more people a practical way to teach AI how to move in the physical world. Small duck, potentially a much bigger on-ramp.